Hi, how you doing today? I hope that you were able to follow the previous lecture. I welcome you to the second lecture on Introduction to Machine Learning. Today we will see the life cycle of a machine learning project, meaning that we will study the different steps that constitute the design and the life of a machine learning project. I think it's important in software engineering to know how we can conduce a machine learning project or to know how to structure a project. It will be quite applied, but we will also try to gather some insight based on a theoretical perspective on designing a machine learning model from the scratch. Hopefully, this lecture will be useful if you want to apply machine learning in the context of academia or industry. All right, so without any further delay, let's start with the life cycle of a machine learning project. So, here we can see that we have different steps of machine learning project that follow each other. The relationship is denoted by arrows. The entire life cycle has been divided in two big phases. The model design, that is there on the upper half, and the operational phase that we can see on the lower half. Basically, the model design phase represents the building iterations of the model, whereas the operational phase is all about deploying and monitoring the model. Let's go deeper so we can see that we first start with the business problem. It can be an academia problem as well. And then we define a goal. We then continue to follow it step by step. Data collection and preparation step, feature engineering step, then follows model building step and model evaluation step. This is the first phase, that is the model design phase, which allows us to build a model. Then we proceed with the operational phase where we follow the steps of deploying the model, serving it, monitoring its deployment, meaning monitoring how the model is performing, and then performing some model maintenance if required. The blue square here corresponds to the machine learning engineering. We will try to cover it in detail, all the steps of the model design phase. Please note that the operational phase is kept for the future. However, we will try to cover it as much as we can. Now, let's go deeper and talk about the business problem step. So, when we talk about a business problem, we are basically referring to an issue that we want to tackle. So, this part is really the beginning. So, it's before doing any code, before doing any data gathering, before looking at what data is available, we just want to focus on the problem, to define it, and to know if we can use machine learning in this case. Let's talk a bit in detail about when to use machine learning. We can consider using machine learning in the following situations. First, if our problem is too complex for coding, meaning that we cannot really do some traditional software development to solve a problem. If we recall, what we saw in the first lecture is that for the problems like image classification, where we have to classify the images, which ones are of cats and which ones are of dogs, it can be really hard to come up with the rules that we can think of applying in a traditional software development. Maybe if we observe and can compute some properties of the images like dominant color or the percentages of some colors, if we think that certain colors are more associated to cats than dogs or vice versa. Overall, it's hard to come up with good solutions in traditional software development, and especially if it's doubtful, because we really do not know. Maybe we analyze some color, or we say that cats have pointy ears or something that we can think of, and we come up with a solution. But is it really a good solution? Hence, we can use machine learning if the problem is too complex for traditional software development to code manually. Secondly, if the problem is constantly changing, machine learning can be good, because we can imagine that if we have a task and if the solution is always changing, so if we provide a manual solution, we may lose a lot of time to come up with the new rules to be adapted manually according to our software, to develop our code, then to change our code, or to refactor or monitor it to adapt to the problem that is also constantly changing. So, if the problem is changing constantly, then the solution has to be more adaptive. Hence, it may be useful to use machine learning because it will be easier to train a new model that will be adapted to the new data than it is to redo code or to come up with new rules to implement and deploy. Thirdly, if we have a perceptive problem, machine learning can be considered to be used. So, for example, if we want to do image recognition or speech recognition or video recognition, then machine learning can be useful. These problems are called perceptive problems because these involve doing some perception similar to humans. So, if we want to deal with that, in computers, generally machine learning is a good solution. The examples of cats and dogs, referring to classification of the images, comes under this category as well. Fourthly, we can use machine learning for unstudied phenomena. So let's say, for example, that if we want to study something in physics, example, um, how gravity is influencing an object that is falling on Earth. Well, we don't need machine learning because this is a well-studied phenomena. We know the mathematical equations, so we don't really need machine learning for this task. But let's say that we wish to study another phenomena in physics that is not well studied, and we don't have a defined formula on how to compute the value that we are interested in. It may be interesting to consider using machine learning in that case as well. Now, next, if our problem has a simple objective that we can quantify, for example, uh, we can answer a question or make a decision by simple yes or no, or we can formulate our problem into having a target that is a single number. So, in a case where we can define a problem in an easy and a simple objective way, machine learning can be considered to be used. Lastly, we can also consider using machine learning in other situations where it is cost effective. So, in any case, we can solve a task using two ways. One is traditional way in software engineering, that is by coding. Another way is using machine learning. Maybe both can be adaptive in that case, but here what we have to think is the cost, because in machine learning we have three main costs. We have the cost of building the model, we have the cost of the infrastructure to serve the model, and the model maintenance. So the cost of building the model is what we have seen in lifecycle preview, that is gathering the data, choosing the model, training it, etc. So it can be costly in terms of time too, for us as developers, but uh, also costly in terms of resources, because training big models can be costly in terms of computing power or computing in general. Also, another cost is infrastructure, because when we want to deploy our model, we have to got to serve it. We have to have an infrastructure to do it. So if it's very costly to do each prediction, if it's costly in terms of resources, if we need a lot of computation to do for, let's say, to predict if an image is a cat or a dog, well, we have to consider its cost too, because it can cost us a lot of resources. Another cost is of model maintenance that we have to consider. So once we have developed our new model, and once we have deployed it, we have to maintain it and to monitor it, whether it is still performing the same way as it was in the beginning and as it was intended according to the data that it was trained on, or whether it needs to be trained on new data. Has the data become obsolete now, etc.? So we have to consider these three major costs. And if these three major costs are less than the traditional software development cycle, then we can consider using machine learning. All right, so these are the few situations where we can consider using machine learning, but it doesn't mean that we can tick on one of the boxes, or we have one of the situations mentioned here, then we have to use machine learning. For example, um, if we have a perceptive problem, but the solution is easy enough to develop, then we may not need machine learning at all. We can just use traditional software development. If we can come up with some rules defined by hand, we can consider solving the problem that way. Now, next, we'll see when not to use machine learning. Well, the meme portrays the idea that it's quite tempting to apply machine learning because it's trendy nowadays and is being used everywhere. But it's really important to know when to not use machine learning, because even if machine learning may seem to be feasible, sometimes it's not good to apply it in certain situations. Sometimes we may feel everyone is using it, so we should also use machine learning, and then there is nothing wrong with that. We need to test and try everything out. But the idea is solutions should be based on problems and not the other way around. It's important to perform a proper due diligence to identify if the machine learning can be adapted. Let's discuss some of the scenarios where we should not use machine learning. It's probably better to not use machine learning when getting the right data, getting good data, is too complex or impossible. So, in that case, if we cannot get data, we cannot learn from it. Also, if we can only get bad data, or the data that doesn't really correspond to the task that we have, um, it will be difficult or impossible to learn. For example, if there is no relation between the features and the labels, if we recall from the previous lecture that for supervised learning, in order to learn, we have to have examples that have both label and features. If we have just a bunch of labels and a bunch of features, but we have no way to make the link between the two, then we cannot perform a supervised learning. We will not be able to learn relation between features and labels if we don't have this relation in the data. Let's take an example. So if we consider the example of price prediction of the houses, that we discussed before, we want to predict the price of housing. In that case, let's say if we have the prices uh, that come from other unrelated sources that are not associated with the houses and their characteristics or their features. And on the other hand, we have characteristic features of some other houses that came from some other resources, let's say advertisements or from unrelated resources of data. For sure, we will not be able to match the two to know which house is available for what price. If we are unable to link the price with the features or characteristics of the house, then it will be impossible to learn and to predict the house pricing. Another case where it will be difficult to apply machine learning is if we have multiple outcomes, but not sufficient examples to train on. So if we have many labels but cannot get enough examples for each outcome, then it will be difficult in this scenario. For example, if we want to predict animals using photos of animals, so preferably we want to have every species or subspecies of animals that we can think of. And we cannot get, and if we cannot get enough data, let's say we have uh, only 10 images of each subspecies, then it will be very difficult to learn something. So generally, we have to have enough data for each label or for each outcome that we want to predict. All right, so another case is that when we know how to solve a problem using traditional software development at lower cost. We already talked about this in the last slide that sometimes we can have two solutions, a traditional software development one and a machine learning one. If we recall, we saw the three main costs in the machine learning. And if the sum of these three costs is expected to be a lot higher than the traditional software development, maybe it's better to go with traditional code and to solve it using a rule-based solution. Let's discuss an example. So suppose we have an exhaustive lookup table that contains the outcome or answers to every input. So if we can go through the lookup table manually to search for an answer for a specific output, then and we if we feel that such a manual lookup can be accomplished, then it's really not necessary to use machine learning. It will be a lot more complicated to use. Maybe it's more fancy to go for a complex machine learning solution, but if we can find such an easy solution with traditional software development, then it's a lot better, and because this will be less costly, easier to maintain, easier to serve, and we will gain a lot of time with this as compared to the machine learning. Also, if time is a constraint and if we have to come up with a solution quickly, it may be better to just come up with the traditional software development tool, although that may not be perfect, but at least we will have the first solution and then we can have sufficient time to analyze if a machine learning can be another solution as a second step or an improvement over the developer coded software. Another case why to not use machine learning is if it's if every decision made by the system has to be explainable. Generally, we can think of machine learning as a black box. So we give some input and we have some output, but it's really hard to know how to explain the decision that was made by the machine learning, because machine learning is kind of an abstraction of learning to make decisions, but mostly it's difficult for humans to understand how the decision was made by the model. Let's try it with an example of decision tree. If we have a decision tree and if it is small enough, then we can interpret it because we have some binary conditions and we can observe which conditions are evaluated in order to predict. But if this tree is complex, it will be really difficult to interpret. If we are within a system that imposes explainability, then for the decisions taken, then machine learning may not necessarily be the best choice. A scenario of such a system can be the GDPR requirement. With GDPR, we have to be able to give explanation. Most of the times, what happens with the prediction by machine learning models is that the outcomes for the same input can change. Suppose if the model provided certain output at a time t, and then at another time we give the same example, and it is possible that we can be provided with another outcome, meaning that there is a change in decision made by the model. So in a scenario where we have to provide an explanation on why the second time the output is different, then maybe machine learning is not the best approach to go for. Um, a related scenario can be, let's say that we deployed a trained model and then we made a prediction with that. Now we retrain the model with some new examples or a new data set, and we got a second model. Now, if the second model makes a different decision than the first one, in such a case, it will be difficult to explain why the decision was different. Another situation where machine learning is not necessarily the best thing to do if the cost of an error made by the system is too high. For example, in a situation where we may lose an insane amount of money if our decision is not good, or if we made an error, then machine learning should not be such a good news or such a good choice. Uh, this is one of the reasons why it's so hard currently to have autonomous self-driving cars. These are hard to design because we need such a good accuracy and such a low error rate that it's really difficult to come up with a good model that makes the right decision every time, because we don't want the cars to cause an accident or to run over people. Hence, the cost of an error is really high in this case. So, in such a scenario where the cost of error is high, we should think twice before using machine learning. All right, so let's move on to the next step in machine learning lifecycle. So we have seen the business problem. We have seen when we can use the machine learning and when not to use machine learning. Now the next step is goal definition. So we have a business problem that needs to be addressed, and we see if we want to use machine learning or not. If we want to use machine learning, then we continue in the life cycle of the machine learning project. So now let's review goal definition.